This is the review for the Unit 2 test. We'll be going over each type of problem that you will see on the test. So we'll start with question 1. You're given two matrices. Matrix P is equal to 2, -1, 6, 4. And we're told that the inverse of that matrix is matrix Q, and that's equal to 1/2, 1/4, -2, and -1/2. So we want to actually test that out by multiplying these two matrices together. And I'll put them up here so we can see the work. And if I multiply them together and I get the identity matrix, then I'll know that they're inverses. Alright, so we've got P and Q, and I'm kind of separating them so I'll have some room to work. And -1/2 is here. Alright, so I'm going to take my first row. This is row 1. And I'm going to put it next to the first column. 2, -1. Multiply 2 times 1/2. 1/2 of 2 is 1. And then multiply -1 to -2. That's a +2. Add those together and you get 3. Alright, so that's the result of the first row times the first column. I'm going to put that in a new matrix right here. First row, first column goes right here. Now I'm going to take that first row, which the numbers are +2, -1. So I'm going to keep these numbers here, but I'm going to jump over to that second column. Alright, 2 times 1/4 is 2/4 or 1/2. And then -1 times a -1/2 is a +1/2. And 1/2 plus 1/2 is 1. Okay, now I'm going to erase those numbers and my work. And I'm going to replace those numbers with the second row. Okay, the second row is 6 and 4. So I'll put these numbers here. 6 times 1/2, or 1/2 of 6, is 3. And 4 times -2 is -8. So add those numbers together and you get -5. That was from taking row 2 times column 1. This is row 2, column 1. The answer goes right here. Okay, now I'm going to multiply those numbers by 6 and 4 times the second column. So 6 times 1/4 is 6/4, or 3/2. We're going to add that to 4 times -1/2, which is -2. I'll just leave that 4/2, -4/2, so I can add, and I get -1/2. So the product of the matrices is not the identity matrix. I was looking for this matrix. If I got this matrix, then I could say that it says X and A. This should be P and Q are the inverse of each other. So we didn't get the identity matrix. We got this instead. So they are not the inverses of each other. Question number 2. We have matrix A and matrix B. What are the results from adding B to A? Now addition is more like what I'm used to. There aren't any special rules that I've encountered. I can add in any order, but the only catch is the dimensions of A have to match exactly with the dimensions of B. So we have 1, 2, 3, 4 rows and 2 columns. So this is a 4 by 2. And if I look at matrix B, it also has 1, 2, 3, 4 rows and 2 columns. So they do match up. I just take the element A1, 1, first row, first column, add those together to get my results. 2 plus 0 is 2. And then I go to A1, 2, row 1, column 2. -1 plus a -4 is -5. Now, to save time, I'm going to start checking and eliminating answers. Go very slow, very careful. And on that first row, I should have 2, -5. So I know I did the work right. That's out. I've got 2, -5 here, 2, -5 here, 2, -5 here. Let's move on to the second row, and we'll multiply that. Oh, I'm not multiplying, I'm adding. Sorry, guys. Looked out the window for a minute. 6 plus 2 is 8. Just simple addition. 4 plus a -3 is a +1. So let's check that next row. 8 and 1. So this is out. That's 3 and 1. 8 and 1. This is out. So this is the only one that works. And you can keep adding. Just to double check. 1 plus 8 is 9. 0 plus 4 is 4. Check. 5 plus 1 is 6. And 7 plus 0 is 7. Check. All right, so our answer is answer D. Adding is easier than multiplication. Multiplication, you've got to remember the commutative rules do not work. For question number 4, we're asked to prove that if we multiply A times B first, get that result, and multiply times C last, we're going to get the same answer if we multiply B times C first and then A last. So let's take A times B, go slowly and carefully. So let's look at the dimensions of A. A is a 2 by 2 and B is a 2 by 3. So we're going to end up with a 2 by 3. So let me go ahead and draw that matrix to give me enough room for 2 rows and 3 columns. And then we'll start multiplying A times B. All right, we'll take the first row of A, which is 4, 3, and we'll stack it up like this. Multiply 4 times 1 is 4, and 3 times 4 is 12. So 4 plus 12 is 12, 13, 14, 15, 16. 16 goes right here. First row, first column. Okay, now we're going to move on to the second row. I'm sorry, second column. First row, second column. So multiply everything from the first row to the elements of the second column. 4 times -1 is -4. And 3 times 6 is 18. -4 plus 18 is +14. Got one more column to multiply. 4 times 3 is 12. And then 3 times 2 is 6. 12 plus 6 is 18. I'm going to give it another look just to make sure I didn't lose any negatives. And then I'll erase those numbers and I'll go on to the second row. Second row is 1 and 5. So multiply 1 times 1, add that to 5 times 4. 5 times 4 is 20. So the second row, first column, is going to be 21. Move on to the second column. 1 times -1 is -1. Plus 5 times 6 is 30. All right, just give it a second look to make sure we didn't drop any negatives. -1 times 30, or plus -1 plus 30 is positive 29. Now we're going to move on to the third column. 1 times 3 is 3, plus 5 times 2 is 10. So that's 13. All right, so now we have the product of A times B. So I'm going to erase this work. And we'll go on and we'll multiply that product times C. So C, I'll go ahead and put C over here, is a 3 by 1. Let's see if that works. Okay, 2 by 3. This is a 2 by 3, and this is a 3 by 1. So we're going to take that out, and we'll be left with a 2 by 1. Okay, so let me draw that 2 by 1 over here. 2 rows, 1 column. Change color, I'll change to green this time. And we're going to take that first row, 16, I'll put it over here on this side. 16 times 0 is 0. 14 times -2 is -28. And then 18 times 1 is 18. Add those three numbers together. And then 28, -28 plus 18 is -10. So that's going to be first row times the first column. So -10 goes in the first row, and we only have 1 column right here. Okay, now I'm going to take that second row and write it next to our resulting matrix over here. The second row is 21, 29, and 13. Of course, 0 times anything is 0. 29 times 2, not taking any chances here, is 58, and that's a -58 because we're multiplying by a -2. So -58, and then 1 times 13 is positive 13. So add that together, and we get -45, and that goes here. Okay, let me erase a little bit. We're going to take that resulting answer and compare it to when we multiply those three matrices, grouping them in a different way. This is the associative property. All right, so now I'm going to multiply B times C. Let's check to see if we can do that. We have 2 rows and 3 columns. I have 3 rows and 1 column. So yes, we can, and we're going to end up with a 2 by 1, which is what we have here that we're going to compare our answer to. This is just B times C. All right, so we take the first row of B and set it next to the first row of C. Now C only has one row. Positive 1, negative 1, positive 3. 1 times 0 is 0. A negative times a negative is a positive 2. And 3 times 1 is 3. So add those together and we get 5 that goes right here. Okay, now we're going to move on to the next row, which is 4, 6, and 2. And I'll go ahead and erase this 2. And we'll put it right here. 4, 6, and 2. 4 times 0 is 0. 6 times negative 2 is negative 12. 2 times 1 is 2. Add all those numbers together and you get negative 10. So that's B times C. Now we're going to multiply that times A. A is 4, 3, 1, 5. So we'll take the first row, which is 4, 3, put it this way. 4 times 5 is 20. 3 times negative 10 is negative 30. Add those two together and you get negative 10. Okay, let me put this matrix that I'm getting the results underneath this matrix that I got by doing this multiplication the first way, grouping A and B together first. So I get negative 10 as the first element. So let me erase my work, give myself a little more room, and I'm going to put that second row, 1 and 5. 1 times 5 is 5. 5 times negative 10 is negative 50. Add those two numbers together and we get negative 45. So we have just shown that when we group differently the associative property, we still get the same answer. Question number 5. We want to know what matrix results from the elementary row operations represented by negative 2 times row 2 plus 3 times row 1. The first step is to decide where we land. So we're going to land at the end here in row 1. So I'm going to rewrite everything in the matrix except row 1. It'll help me keep things organized. So row 2 is not going to change. Row 2 is 8, 1, and 3. So let's go ahead and multiply by the scalar negative 2 and 3 for each of these. Oops, I got this backwards. We're multiplying negative 2 times row 2. So let me put that down here on the bottom. Okay, and then I'll do that before I move on to this second part. Okay, so I'm doing this part. Negative 2 times row 2 gives me negative 16. Negative 2 times 1 is negative 2. Negative 2 times 3 is negative 6. Now I'm going to multiply row 1 times 3. 3 times 3 is 9. 3 times 5 is 15. And 3 times 2 is 6. And then we add those together. And then we're going to replace those where the numbers in row 1 were. So negative 16 plus 9 is negative 7. And then 15 minus 2 is 13. And then 6 take away 6 is 0. So step number 1, identify where the answers will land. Rewrite your matrix and then leave that row or column open. And then multiply -2 by all elements in row 2. We did that. Multiply 3 by all elements in row 1. Add your results together and insert into row 1. And check my arithmetic. I don't have an answer to check by, but hopefully I did it slowly and carefully and we got the right answer. All right, -25, 17, and 0. What did I do wrong? -2 times row 2. Let's just take another look at it. And we got -16, +2, and -6. And 3 times row 1 is -9, 15, and 6. So I must have made a mistake with my negatives. 9, 15, and 6. It should have been -9, 15, and 6. Okay. All right, so here's the work so that you can take notes and look. But look how easy it is to make mistakes. Make sure that you have the notes written down when you take your test. This is going to go in as a completion grade, but I need you to do your best. Okay, both parts, just get it done. All right, now we have question number 6. We want to find the value of A. So it says, suppose that 2/5 times A plus 6 times this 3 by 1 matrix is equal to this. We want to find the value of A. So it's easy to multiply a matrix by a scalar. And a scalar is a number. This is a number. So I'm going to be multiplying 2/5 A plus 6 times each of these elements in the matrix. So I'll have 3 times 2/5 A plus 6, and then I'll have -2 times 2/5 A plus 6, and then the third number is going to be 7 times 2/5 A plus 6. Okay, now all of that's going to equal to the corresponding number in this resulting matrix. So the first one is going to equal to 15. The second one's going to equal to -10. And the third one's going to equal to 35. So let's pick one of those equations and let's solve for A. We'll take the first one, and then we've got to distribute 3 into each of those terms. We get 3 times 2 is 6 over 5, A, plus 3 times 6 is 18, equals 15. I'm going to subtract 18 from both sides, and I have 6/5 A is equal to -3. 15, 16, 17, 18. Okay, multiply both sides by the reciprocal or the inverse, 5 over 6. I'll put the 3 over 1, multiply by 5 over 6. And 3 goes into 3, 1, 3 goes into 6, 2. I have -5/2 is the value of A. Now if I try the other two equations, I should still get -5/2. So I'll do that to check my work. -2 times 2 is -4/5 A plus -2 times +6, -12 equals 10, -10. All right, I'm going to add 12 to both sides, and we'll get +2 on the right is equal to -4/5 A. So multiply both sides by negative 5/4, the inverse, times negative 5/4. You can put this over 1, keep everything straightened up. This is all going to cancel. And you'll get A is equal to 2 goes into 4, 2 times. Get negative 5/2. And if you solve the last equation, you're still going to get negative 5/2. I just did that to double check. So the value of A is equal to negative 5/2. All right, for question number 7, we have a system of equations. We're going to solve the system using Cramer's rule. So we set this system up as an augmented matrix. I've named it matrix Q. You can name it whatever you like. And I'm just going to take the coefficient matrix, which are all of these numbers in front of the x's, the numbers in front of the y's, everything's lined up. And I'm going to find the determinant of that matrix. So the determinant is going to equal to 2 times 4, which is 8, minus negative 3 times 1, which is a negative 3. So the determinant is equal to 8 plus 3, or 11. Now hang on to that because we're going to need that in every one of our steps. So remember what the determinant is. All right, so we did step number 1. Okay. I didn't really write the coefficient matrix. I just kind of looked at it from here. Coefficient matrix is 2, 1, negative 3, and 4. Okay. And then I took the determinant of that. Let me change my pen color. The determinant is a positive 11. All right, now we're going to write the X matrix. Okay, the X matrix is where we take the coefficient matrix, which was 2, negative 3, 1, and 4. I'm going to take my X's out. So my Q matrix, call it our X matrix of Q, is going to equal to the coefficient matrix, where we take out the X coordinates and then we replace it with the constants, 0, 22. We're going to write the Y matrix. Okay. The original matrix Q, we want the Y matrix of that. So we're going to take out our Y's, leave our X's, and replace the Y's with the constants. All right, now I'm going to change my pen color, and we're going to find the determinant of the X matrix. So 0 times 4 is 0, minus 22. So that would be, the determinant of this matrix would be negative 22. Okay, now we're going to find the determinant of this matrix. 2 times 22 is 44, minus 0. Okay. All right, now we take each of these numbers and we put, if we're looking for the X, we put, this is our X matrix. We put that determinant over the determinant of our coefficient matrix, which is 11. So X is going to equal to, when we simplify that, negative 2. To find our Y, we take our Y matrix. The determinant of that was 44. We put that over the determinant of our coefficient matrix, which was 11, and Y is equal to 4. Okay, so our solution is -2, 4. All right, so here's just step by step what I just did because it's easy to make mistakes when I double check. We write our augmented matrix. Okay, the X's are in red, the Y's are in green, and the constants are in blue. And then I'm going to take that first part, which is the coefficients. That's our coefficient matrix. I'll call it Q sub C. Then I'm going to write the X matrix from that original matrix. I'll call that Q sub X. We get that by taking the constants and replacing our X values with those constants, keeping the Y values. We do the same thing to get our Y matrix. We replace the Y values with our constants and keep our X values. Okay? When we find the determinant of the coefficient matrix by multiplying 2 times 4 minus -3 times 1, if you remember that was 8, 9, 10, 11. Okay? Then we're going to find our determinant of our X matrix. If you remember that was 0 minus 22, -22. We're writing that. If you look, these symbols, they don't mean absolute value. They're another way to write determinant. Okay? And then we're moving over here to the determinant of the Y matrix. 44, take away 0. And then we just put Q of X, which is right here, over the coefficient matrix, the determinant of each. So that would be -22 divided by 11, and X is equal to -2. Okay, we do the same thing for Y. So I'm just kind of checking my work. And I'll do the same thing for Y. Just going slowly, double checking. Question number 8. What matrix results from multiplying matrix A by the scalar -5? Now I love these because we're just multiplying by a number. So we're essentially taking that number, multiplying every element inside this matrix by -5. So the resulting matrix, I'll put it over here. -3 times -5 is +15. Okay, -5 times +2 is -10. -5 times -1 is +5. Move down to the second row. -5 times +5 is -25. -5 times 0 is 0, and -5 times 6 is a -30. Question number 9. All right, we're basically given 1, 2, 3, 4, 5 matrices. And let's write down the dimensions. A is 4 rows and 2 columns. B is 2 rows and 2 columns. C is 2 rows and 1 column. D is 2 rows and 2 columns. E is 4 rows and 2 columns. Now, what can we do and what can we not do? So let's just take and find out which operations are defined. Can we subtract A from E? I need to get a different color because this green is not showing up. All right, can we subtract A from E? We just have to check to make sure that they are the same dimension or the same size. So look at E, it's a 4 by 2, A is a 4 by 2, and the answer is yes. We can add and subtract them. What about B and D? B is a 2 by 2, and D is a 2 by 2, so the answer is yes. Okay, now we're going to look at C and A. Those are different dimensions, so we can't add or subtract them. And C and B, those are still different dimensions, so we cannot add or subtract them. Now we want to determine the inverse of matrix D. All right, here's your hint. First, find the determinant of matrix D. So the determinant, you're going to cross multiply and you'll get -3 minus whatever this product is, -6 times 4. And 6 times 4 is 24, and that's a -24. When you subtract a negative, it becomes a positive, and you add it. So 24 take away 3 is a positive 21. So that's what the determinant of this matrix is. Okay, we're going to put 1 over the determinant, and we're going to multiply that by the matrix D, but we're going to change the places of A with the little d, little a, little d, change places. Make sure you bring your signs along with you. We're not going to change the places here. We're just going to change the signs to their opposite. So this is going to be a +6, and this is going to be a -4. Now we're going to multiply through to get the inverse. So 1 times anything is that thing, and that thing that we're multiplying is the fraction 1 over 21. -4 times 1 over 21 is -4 over 21. 6 times 1 over 21 is 6 over 21. And then -3 over 21 is -3 over 21. -3 times 1 over 21. I think I'm leaving some things out when I'm talking. All right, so that's the inverse. Let's see if we can reduce anything. 1 over 21 is in lowest terms. 3 goes into 6 2 times. And 3 goes into 21 7 times. Okay, -4 over 21, we've got to keep that. They do not have common factors. But we can divide 3 into 3 and 3 into 21, so we get -1/7. All right, so this is the inverse. Okay, just double check my work. So easy to mess up, and it looks like I got it right. So work slowly through this test, take your time, and I will go back and give you credit for giving it your best effort. All right, now to check your work, when you have the inverse, you would take each row, remember how you multiply matrices, take the first row, multiply it times the first column. Second row, multiply it times the second column, get your new matrix, and you should get the identity matrix 1 1 0 0. Okay. All right, think. Now we have a word problem. We did this in lesson 2.03, and it's similar. Farmer Wilson sells seeds. Sounds like a tongue twister. He sells 3 kinds of beans: navy, black, and pinto. Matrix A shows the price of a pound of seeds at 2 of Farmer Wilson's stores in different parts of the state. So this is going to be navy, if we're labeling it, black, and pinto. And this is store A, store 1, and store 2. Now the inventory system holds information about the number of sacks of seeds that are on the shelf and stock room of each store. So this matrix shows this information. So remember, the inventory system holds the information about the number of sacks that are in the shelf and the stockroom. So this first column is sacks on the shelf, and this is sacks in the stockroom of navy, black, and pinto beans. If you're trying to organize and visualize what this is. The question is, how can we use these two matrices to find the total price of the sack of seeds on the shelf and in the stockroom at these two stores? So we take the product, we multiply these two matrices together. This first one, matrix A, is a 2 by 3, and matrix B is a 3 by 2. So we're going to end up with a 2 by 2. Okay, so these matrices, when we multiply, we would get a 2 by 2 matrix where the rows represent, well, let's take a look at this now. So the rows are going to represent the different stores, and the columns represent, so these are the stores, store 1 and store 2. And I'll show you how to look at that in just a minute. And the columns represent the location of the stock, where the stock is, on the shelf or in the storeroom. So let's take a look at that to see how we would know that. All right, so if we're multiplying A times B, we're multiplying store 1 times, look at the column. Okay, the column is shelf and stockroom. Okay, so it's telling us the stores in store 1 where the stock is located. And then if you multiply these out, you'll get, I think it's 312. But basically, remember, you take that first row, multiply it to the first column, each number, and then add those together. Okay, I want to continue and get the last one. I'll leave that up to you. But these are the types of questions that you'll see on the test. Do your best and let me know when you're done.